So what we have here is something a bit different. As you probably know, we primarily do business two-way radio, and we just do the citizens band radio to help some of the trade customers that we have in that subject. But of course, we've been doing the videos on citizens band radio because it helps people. So this is a business radio which is elderly. It's a Tait 500 series, Tait T530 from New Zealand, and this is a T530 if I remember correctly. If I can see the serial number and all that's on the T530C/3. So these are 1989-ish. So you know they're getting on. They're 30 years old, and this belongs to a radio ham friend of mine. And he wants to use it on his automatic packet reporting system on 144.8. I think it's already on frequency, but he just wants it servicing. And I'm going to make sure it's been put on frequency correctly. I've got an extract from the service manual. You know what? It's probably 20 years since I saw one of these sets, because you know they've been superseded many times over. Having said that, most of our customers don't have the latest models. That doesn't really bother us. The speaker unplugs from there, so we can just unplug it and remember where to put it back. Probably they're a bit flimsy, they fall apart once you take the it's not plastic, it's some kind of carbon fibre. I'm going to take both the boards off, both the cases off. There we go. I think we better glue that back on because that's going to end up shorting out the PA. The 25 watt said it's got a screw missing. That's actually important, but you know, there you go. I don't know why that's happened. That's not good, and I don't know what that's doing across there, because there shouldn't be any oddball capacitors. So I'm not even going to try it. These radios suffer from being microphonic easily, and that's where you press transmit, go tappity tappity tap, and it actually starts transmitting as if you're doing it down a microphone. And one of the main reasons for the microphony is this VCO can. I'll just take the display shroud and the front off, seeing as it's fallen off. There's no mic on this, doesn't need a mic, it's not for that. So I'm not sure how he thinks I'm going to set up the deviation. I'm obviously not, am I? Really am struggling to get that one out, and I've got the right screwdriver. These are £376 plus purchase tax VAT in this country. Not sure why we had that screw shenanigans. And what we need to do is to clean the print for a start with a fiberglass brush, which we'll no doubt have to pinch off Mr. Chippy's bench. We'll go through everything else first. The other thing, without a mic, I'm not sure how we get this into transmit. I suppose we have to short out the things with a crocodile clip lead. So basically, these are a synthesized programmable radio. Crystal filtered, work well apart from what I mentioned, microphony. So we're going to get the fiberglass brush all around there, and we're going to get these cases onto some emery paper to make sure they're clean, and that usually is the problem gone. That's deviation. So we're going to assume he's got that right. There's an optional CTCSS board can sit in that position, and that's what that pillar's for. Right. So we're going to... Oh yes, so the way... How is it programmed? Well, there's a diode matrix board. Icon Business Radios did a similar thing. So on here, and I'll just zoom in, we have a subboard full of 1N4148 or 1N914 diodes. You've got two channels. It says RX2, RX1, TX2, TX1. So it's straightforward which row you're dealing with. And you make up an N code, that's N as in November, not N code as in ENCODE, an N code, and that is in the service manual. And that is here. And all I need to do is to get a calculator. And this shows a later model with the surface mount version of the board for the T535. See, it is the 535 service manual. Don't know why we've got that on. We'll get rid of it. What I'm going to do is go and get a calculator. So here we are with the filthiest calculator I've ever seen in my life. I don't know whether the normal one is. Believe it or not, this came from a pound shop. Believe it or not, it cost £1. So, we have the frequency, we're told, it's just the one channel. And what he wants is 143.8 megs. Now these are high band business radio, but they will go onto amateur radio 2 meters. But there's a link in this VCO section you've got to make. It's probably been implemented already, but I just wonder sometimes, you know, when you see a capacitor on the bottom like that, you think, has somebody not realised there's a link? I don't know. We'll find out. So where are we? There's the calculator. So he wants 143.8 on transmit and receive, and that needs to be at 5 watts. So the radio is a 25 watt radio, so we'll have to make sure it's properly tuned and then turned down, so there's no harmonics. Although at least with amateur radio, the harmonics go into the next amateur band, as in 3.5 megs, 7 megs, 14 megs, 28 megs, and so on. So we're on the 2 meter amateur radio band. Sure, it's 143.8. Anyway, if that's what I'm sure that's what he said. I can always call him on the radio. So, calculator. So what happens is this. So for transmit, so we'll do TX first. We'll do RX next. Okay. So we start with, we've got this figure of 143.8, so we'll put it in our calculator. Minus, our first N number is 9, N9. So I need to write N9 there, and we deduct, so minus 128. Okay, so that leaves us with 15, doesn't it? We'll look down this chart. 15, no, 8. 8 is N5, so our next one is N5. So we need to deduct 8. That leaves us with 7.8. So what's our next one down? Well, it's 4, so it's N4, as it happens. So minus 4 leaves us with 3.8. So our next one on the chart is 2, which is N3. We'll take away 2, that leaves us with 1.8. 1 on the chart is N2. So take away that. And that leaves us with 0.8. 0.8. So the next one is 0.5. So that's N1. So 0.5 minus, that leaves us with 0.3. And so our next one, well, what we're going to do, we'll use two and 1 to achieve that. Sometimes, yeah. So we'll use A5, which is the 0.2, and A4. And if I take away the 0.2 and the minus 0.1, we've got supposed to have got 0, and we have got 0. Now on receive, it's different, because we've got to take away, first of all, the IF. So we're going to again start off with 143.8, and we're going to deduct the IF, which is 21.4. So if we take away 21.4 from there, so minus 21.4, it now gives us 122.4. So the receiver is minus 21.4 megs, which is the IF. The loss of CB radios are 10.695. So this is double 10.7. 10.7 is normal in business radio, or 21.4 on later models. So we've now got 122.4. So once again, we go down this chart. Have we got 128? No, we haven't. We've got 64, so it's N8. So we take away 64. What's that leave us with? 58. Next one's 32, so it's N7. So we now can take away 32. That leaves us with 26. So the next one is 16, which is N6. So take away 16. Now leaves us with 10.4. 10.4, good buddy. N5 is 8. Take away 8. That leaves us with 2.4 and 3. So we take away 2. That leaves us with 0.4. So our next one, 0.5, is no good to us. So I don't remember 0.25. I must be losing my marbles. So it's 0.4 we're wanting to get rid of. So it's going to be N0. That's 0.25. That leaves us with 1.5. So A4, which is 0.1. And then A3, which is 0.05, and we've got 0. So that's how we've got it. So that's the transmit line, that's the receive line. So they're the diodes that need to be cut. I think on ICOMs it's the other way around. I think it's the ones you leave in. I'm sure it's programmed right. But I've done this to just show. So I'm going to go down this board. They're all. We start with N9 at the top. So on transmit, I should have N9 open. I have closed. Interesting. I might have got this frequency wrong. Yeah, because they've got N3. I might have got the frequency all in my little mind totally wrong. Anyway, I'll put that board back. It's probably 144.8, 143.8. Wouldn't even be in handband, would it? I don't use 2 meters. I've been on it about twice, so I wouldn't know. I'm a 77s person. Oh yes, I'm the UHF man. So, and I was doing UHF, you know, in 1979 when you had to be converted business radios. There was very, very little commercially available. It was known as the gentleman's band. Right. Now, so what's these bizarre things? He's an electrician, you see, so he's bound to have something bizarre. Are these kind of reusable chock blocks? Ah, it could be. Oh, we've got some poxy bit of wire we can put in there, because this bench isn't geared up for this kind of thing, you see. We're also going to have to use the more hefty power supply. We normally use the 3 amp power supply because UKCBs never go over 2.5 amps, and that's only the latest ones that even do that. Most of the UK 1980s models don't go much over 1.6 amps, which is quite handy because most 3 amp CB power supplies don't really give more than 2. But we've done all that before. Right, so there's our 18 amp power supply on, which I'll make sure is at 13.8 volts. It's an analog meter power supply, and you know, it's a bit difficult. 13.7, that'll do. So somehow I need to connect this up to the radio. Well, we know it's negative earth, so that's easily achieved. Oh, we can probably take these off. Yeah. You see, I learn something new every day. It's lucky it is going to be at 5 watts because my leads like 6 amp maximum. So if I switch the radio on, and we've got dodgy power plug syndrome. Could be that these need a bit of tightening, or it could be that the earth's gone AWOL internally. I think the earth's gone. Yes, he didn't tell me that. What can happen if you're running these at 25 watts is this earth terminal can actually burn out. No, but it hasn't on this one. No. So you can end up having to put a wire through, which would be difficult replacing the actual pin. So we used to kind of put a wire through. I wonder why it's a bit dodgy on the power connector. I'll get that meter back. You couldn't make this up, could you? Does it work? It's working. It just wants a bit of a service. Well, whatever I've done, it works now. and channel 1's the up position, channel 2 would be the in position. No, we've gone off again. That's call if you've got selective calling in the middle. So we're on, and we'll start with transmit. Actually, I'll take the power off, and we'll take this VCO, that can off, just so you can see the trimmers underneath. So we've got. Oh, it's had the reverse polarity problem. It's not just CBs, you know, business radios as well. So we've basically got 3 PA adjustments, if I remember correctly, without looking at the service manual, which is the variable capacitor there and 2 variable capacitors there. So, what we start off doing, I'm just going to see whether this is transmitting on something near where it wants to be. So let's put the other camera on, so we can see what frequency it's on. So to go into transmit, I'm going to have to just kind of short this out, aren't I? Right, so that's brought us into transmit, and we're on 144.8. So it was 144.8. I did 143.8. I knew there was something wrong as soon as it was not right. And at the moment, if we go to camera 1, we're doing how many watts? We're doing a bit more than we need to be. So it's doing 6 watts. We'll turn that down. I think his license for this is 5. So what we need to actually do is to turn the power up to turn it back down. So we've got a peak there. See, it's not being tuned right. If it's not tuned right, we're going to get spurious emissions. Or a blown PA. Now I've timed out. There is a timeout timer on these radios. So we're nearly full scale deflect. We're beyond full scale deflection now. So as you can see, it's 30 watts. So now I'm going to turn it down with the power preset to 5 watts, which is where it needs to be. So now you can see it's actually set properly, because if you remember, it was about 8-9 watts at full power on the preset, because none of this had been aligned properly. So you know, that's what we're here to do. So as far as frequency goes, we'll go back to that. It's supposed to be 144 point. I mean, this is neither here nor there, but it's the trimmer just there. So just pull that up a fraction. Now another thing is, these radios can frequency hop. What happens is, it's timed out, that's fine. What happens, I'll turn the power off, is this subboard, it's been modified on this, carries the crystal, the reference crystal, and it needs the pins soldering directly down, and it's been done on this, because carrying that reference oscillator crystal through the tin plated pins is absolutely rubbish. And even when these were new, they would frequency hop because of that. So that has been done. We'll just check once again. 5 watts, 144.8. Now he'll have got the, I'm sure he'll have got the deviation exactly where he wants it for his project. What I haven't done, which is the most important thing, is to check the VCO lock. Or to check what I said I was here to check, which was the link in the VCO box. I don't think I've done the bit of the printed the bit of the data with that on, but there's a link underneath. If you're going under 145 megs, you make the link, and you know what? I think it's just there, and it's been implemented. So I will be going. I say we've still got to clean these VCO cans. So the most important thing to do on this is to set the VFO up, and what we need to do is to put that on chassis. There's negative earth, as I have said, and we're looking for 3 volts. So centre pin there, you've 3 pins, 1, 2, 3. The centre pin is 4.23. It's supposed to be 3 volts. So what you do, you set the transmit first, because they're interactive like they always are. And let's have a look where which one's done which. So CV291 is the one on the left and 292 is on the right. It's test point 2, and it's the loop is the center. So we'll just look at what that says. Receive is it's 4 volts, not 3. I remembered wrongly. So this is going to be as near as possible to 4 volts as it can be. So 4.04 on receive. So 3.99 toggling for now on transmit, 4.09 on receive. So it's, I don't know why I've this has gone asked about what's it, but it's transmit is the right and receive is the left. And you know what? If I'd have looked at the can, it tells you. This is what happens when you haven't looked at one for 20 years. So we've gone through the N codes. It wasn't relevant to this set, but I've shown you how that's done. So these are business radios for high band. They're supposed to be operating like 160 to 174 megs, but they will go down onto amateur radio 2 meters because of that link underneath. So that's told you that. Now we're going to have to hook receive up to this somehow. So we're going to put our crocodile clip lead onto the speaker output, and it's that one, isn't it? Turn the squelch down. You know, I've got 143.8 on my mind, 144.8, and then we have it on the signal generator. There you are, 144. That wire's in the way of the one, but it's there. So now we're going to tune it like we would. Oh, it's as deaf as a post. No wonder it wants it servicing. So it's doing 2.1 microvolts. See, this has shown it twice, hasn't it? On transmit, none of this had been lined up, and so it was, the SWR was out into stage, and of course that can lead to component failure. They're very rugged, but if it's supposed to be doing 25 watts and it's all mistuned, the internal SWR is wrong. So we've sorted that, and just looking at that result, you have got to tune the sets. Which are the coil numbers? I've just failed to remember which is which. Might just have a look at this. What does it say? 19, 15, 13, 12, 10. 19, 15, 13, 12, 10. So it's 19, 15, 13, 12, 10. 19, 15, 13, 12, 10. So we'll now go over to the SINAD meter, and we'll put about 4 dB on there. Certainly wasn't much improvement there. This one is broken. Luckily, I can grip enough of it to adjust it. Let's put a bigger signal on, because I think this is some kind of detector. Yeah, it is. Go back to 4. So I wouldn't say that was mind-blowing by any standard. It's really at the end of its operational frequency it will do. You know, it really is. You know, you'd have to start changing capacitors and rewinding coils to make this better. So what is it doing? It's pretty lousy. For the 12 decibel SINAD, it's now doing 1.2 microvolts. So we're now 1.2. So that's all that, I mean, that is all the difference, isn't it? But it's still 10, looking at 1 microvolt. So that's listening to 1 microvolt through the radio. 0.8, 0.7, 0.6, 0.5, 0.3. Just about here 0.35. And I really would have liked to have been able to hear 0.3, but it's a high band radio, it's now on ham band, and it is never going to be better than that. It's certainly better, but it's a packet reporting thing, so I think it's more transmit than it is receive, to be honest, and that's certainly a huge improvement for him. So that is, I knew that was the detector, and I remember the rep coming around and said, "No, don't ever touch that. No, it's a factory set one. You can't adjust that." Well, there you are. So we're done. We're done. So we've covered the transmit. That was perfect. It was capable of doing 30 watts even out of band. We've done the receive. Not as good as I would like it, but everything's adjusted. There's nothing faulty. It's just beyond the capability of the radio for the frequency selected. I'm just going to check for legal reasons what channel 2's on. So we're going to change to channel 2. I'll switch the frequency counter onto my thingy. We don't need to look at it on the spectrum analyzer because everything will fall in another ham band. So let's make it go into transmit. It's 145.550, so that's calling channel, so that's absolutely fine. I didn't want it to suddenly come up with some marine frequency or something, you know, stupid, which could always happen. We once got into some hot water when I was at Nottingham Radio, and we'd sent out there were these kind of radios as well on short-term hire to a taxi firm, funnily enough at Grantham, and they decided that they found channel 2 on the radios clearer, but they weren't licensed for channel 2, they were licensed for channel 1, and powers that be came to see us and realised it was an error that we hadn't blocked off channel 2, because what you do to block off channel 2, all you have to do to inhibit the transmit is solder up the N9 diode, which is open, because if you solder up N9, it's such a big thing, it's not going to do anything, and it's actually been disabled. So he's got no receive on there, N9 is linked up, so chances are it's disabled. But anyway, that's what happened, and you know, they had to do a statement and all that. I mean, it wasn't me personally, but these things can happen, and you can end up with people on a frequency they're not supposed to be on. And then you get, you know, another business will complain and say, "There's somebody on our channel. You know, these channels are allocated every 30 miles or whatever, and that just shouldn't be happening." I think it was taxis versus mini skips. So that is that. So he'll have got the deviation. I need to piece this together and turn the power off in so doing. So had this not already been on 2 meters, there wouldn't have actually been that much more twiddling. I'd have had to have made that link up, and that transmitter was just so far out, it was unbelievable. So I'm just going to go and get some sandpaper and a fiberglass brush, and I'll just deal with that. Right, there we go. So we've got some emery paper, fiberglass brush, so I'm going to just go around the printed circuit with the fiberglass brush, and on the reverse side, just to help get rid of some of that microphony. So on a flat surface, clean. There we are, clean. Wave goodbye to microphony. I should drop all the screws on the floor. I've recovered one. That's one in. I'll do the rest later when I pick them up off the floor. I'll look in our scrap box and see if I can find a screw. They're a bit weird. So that's it. A Tait T530 VHF high band business radio on 2 meters on a specific frequency for his packet reporting thing. And hope you found that interesting, because these can be picked up for very tiny money and can be a cheap and robust way of getting on the air. So thank you for watching.